All right, on this first one, whenever you're given a word problem, the very first thing you're going to want to do is draw a picture that goes with the word problem so that you have everything labeled appropriately and you know which side you're working with. Okay, so based off the information that they gave us, we were driving our car towards a mountain. So I have my mountain, I have my car, I have my right triangle in there, and we're going to label it with the information they gave us. They told us we were 4 miles, which is the same as 21,120 feet. We're looking for the height of the mountain, so that's our x value, and they gave us the angle of elevation, which is the 2.8. Okay, so before we can solve, we have to think about what trig function we're using. Okay, so I always use SOHCAHTOA. When we have SOHCAHTOA, we have to look at the angle and what two sides we have in representation of that angle to figure out which function to use. So here we've got opposite and adjacent, so that tells us we're going to use tangent. And you're going to go ahead and plug that information in. And to solve for x, you just need to multiply the 21,120 to the other side. When you plug that in your calculator, you'll end up with 1,033 feet. On this next example, if we're going to find all of those trig functions, we're going to need all 3 sides of our right triangle. So we're going to go ahead and solve for the missing side. To do that, we're going to set up our Pythagorean theorem. When you go ahead and solve that through, you end up with x equals 5. Okay? When you notice, when you look at that triangle, the 2 legs are the same length, which means we're actually working with a special right triangle. Our special right triangle there is a 45, 45, 90. And it breaks down into, if the 2 legs are each 1, then the hypotenuse is going to be the square root of 2. If we use this triangle that I drew in over on the side instead of the one that they give us, then all of the simplification is done for us. We don't have to worry about canceling the 5s and everything. It'll just save us work in the end. Okay? So again, when we're setting up our functions, remember that sine's opposite over hypotenuse. That's where SOHCAHTOA comes in. So when we pick from our theta opposite over hypotenuse, we end up with 1 over square root of 2. 1 over square root of 2 is improper because the radical is in the denominator, and we don't leave it that way. Okay? So to rationalize the denominator, we're going to multiply the top and bottom by square root of 2 over 2. And we end up with square root of 2 over 2. Sorry, we were multiplying by square root of 2 over square root of 2, and we ended up with square root of 2 over 2. Remember, the cosecant is just the reciprocal. It's hypotenuse over opposite. So we're going to end up with square root of 2 over 1, which simplifies to square root of 2. Because this was a a 45, 45, 90, sine theta and cosine theta are the same, and cosecant and secant theta are the same, so we don't have any work to do there. And then lastly, for our tangent, opposite over adjacent, we get 1 over 1, which is 1, and the same for cotangent when we flip it to adjacent over opposite. Again, on number 3, it's really important that we start with an accurate drawing, given the information that they've given us. So it's important that we label correctly. They told us that angle C was the 90 degrees. They told us angle B was 36, and side A was 23. So side A is across from angle A. They ask us to go ahead and find the 2 missing side lengths, which are side B and side C. So you just have to go ahead and pick one to start with. We're going to go ahead and solve for B first. If we're looking for B, we're given angle B, looking for side B, and we have side A with the 23. So the 2 side lengths we have there are opposite and adjacent, so that's going to be a tangent function. Tangent of 36 equals the opposite side over the adjacent side. And to solve for B there, you're just going to go ahead and multiply both sides by 23. And when you plug it in your calculator, you'll get 16.7. Okay? So if given the information we have, we still need to find part C, or side length C. So given the side length that is 23 and side length C, given the angle 36, that's adjacent and hypotenuse. So we're going to set up a trig function for cosine there. Adjacent over hypotenuse. And whenever you're solving for the denominator and the other side switch places. So C and cosine of 36 are going to switch places to solve. And you end up with 28.4 when you plug that into your calculator. All right, lastly on this problem number 4, they're asking us to work with this triangle. And again, this is a special right triangle, which is a 30, 60, 90 triangle. Okay, you have to be really careful because the way that they labeled it, it's not drawn to scale. The shortest side looks like it's across from the 60. So I've gone ahead and drawn in a 30, 60, 90 triangle with the side lengths labeled over there. Okay, to find x, our missing side length, that's the short leg. So the hypotenuse is always double your short leg. So working backwards, our short leg is going to be half of our hypotenuse. So we end up with 9/2 or 4.5. Okay, the next thing they're asking us to do is find the cosine and tangent. I'm going to go ahead and label that in there with simplified numbers. Okay, if we plug 1 in for each of the x's in that first purple triangle, we end up with the short leg is 1, the long leg is square root of 3, and the hypotenuse is 2. That's going to make it much easier for us so that we don't have to worry so much about simplifying when using like 9 and 4.5. Okay, so the first one, they ask us to find the cosine of 60. Cosine, again, is adjacent over hypotenuse. Okay, so we end up with 1/2. You have to be really careful. On the next one, they're asking for tangent of 30. So they've switched angles. Okay, and we're going to do opposite over adjacent. Okay, so when we do that and we plug the numbers in, we end up with 1/3. Again, that's not rational, so we are simplified, so we have to rationalize the denominator by multiplying the top and bottom by square root of 3, and we end up with tangent of 30 equals the square root of 3/3.